Okay, so in my previous demo I was showing this LED strip with the controller here. You can use the remote to turn it on and off, change colors, but all the LEDs are the same color. This one uses 12 volts, so I have like that 12 volt power supply over there, well 12 volts-ish. You can just take the current down by taking the voltage down. There's actually a lower brightness button, but it only works on full colors. Once you go into auto modes or fade modes like these, they go full current. You can see it's very bright, and there's nothing you can do to take the current down except taking the voltage down. So that's what I've been doing. Anyway, so those are for those boards. Now the cool board I found is this little guy, which is, instead of using a remote control, is actually Wi-Fi. It's an ESP8266 inside, and thanks to that, I can actually use my cell phone to again talk to the strip and change colors, but it will be the same color for all the LEDs, which is not what I want. So that's where the Neopixels come in. Neopixel rings come in different ways, or in this case strips. The way they work is you have 3 wires. I'm trying to zoom in. You have 5 volts, then you have DN, data in, and then ground. So this is wired in a different order than the servo cables I'm using. So I'm rewiring this servo cable to have the signal in the middle and ground and 5 volts. This goes to a power converter board here, which is just taking the same voltage and signal and multiplying it. This is actually all servo stuff from my RC remote control planes. And this 5 volts goes to this little capacitor as recommended by Adafruit. That's just to prevent current onrush from damaging the pixel. In there I have a resistor for the data line, and it's going to an Uno. So the Uno is really just sending a data signal, and the 5 volt is coming from that power supply over there. You can see right now my strip is taking 2.1 amps, which will be way too much for an Arduino board, which is why I have that the power supply. Now it's actually not using all the LEDs, which is why it went down to 0.9 amps. Okay, so that's how the system works. The way you connect it, I'm going to show you here. Each strip has a D in and D out, so each pixel is connected to the next one. I thought you could just connect in the middle, like I would do here, and nothing happens. So what's going on is that the D-in that I'm connecting to is also connected to the D-out of the previous LED, and that D-out actually sucks the signal out, which prevents it from working. So you can only connect to the last LED, or I should say the first one in the strip. And I'm going to try to do this here. Okay, so that shows you the connections. Red, 5 volts, white is the data line, and black is the ground line, and I'm using those pins to connect. You can see better if I turn off, because of course the LEDs tend to be a little bit too bright for the camera. So that shows you how it works. If you have a strip not working, again, you cannot just try connecting to the pixels in the middle, because each pixel before that is going to take your data signal and suck it down to ground, preventing it from working. So you can only connect to the last LED, and if it doesn't work, you have to cut it off right here and connect to the next one. So now the interesting thing is, how do you actually do the controller board, and which kind of software you can write to talk to it, and I will talk about that.